Hi YouTube, Timothy Unkert here. In this video, we're going to solve quadratics where a equals 1. First though, let me talk about the steps. So step 1, make sure one side of the equation is equal to 0. If it's not, you're going to have to rearrange or subtract or add something to get one side equal to 0. Step 2 is you're going to find the factors of the constant term. That's typically called c when you have a quadratic of the form ax squared plus bx plus c. Step 3 is to find the pair of factors that add to the coefficient, which is the number in front of x. We typically refer to that as b. And then step 4, we're going to write that in factored form. And then in step 5, we're going to use the zero product property. And the zero product property basically says if you multiply a number by 0, your product is 0. So we're going to use that principle to set each of the binomial factors equal to 0, and then we're going to solve for x. And a lot of times we'll have two solutions. Sometimes we'll have one. This video won't cover it, but there are some times where you don't have any real solutions, and those are when the parabola doesn't cross the x-axis. Okay, so let's get to some examples, and hopefully you enjoy the video. Okay, in our first example, we're going to solve for x. We have the quadratic x squared minus 6x plus 8, and that's equal to 0. So we already have one side of the equation equal to 0, so we don't have to rearrange anything. So we're going to start by listing the factors of the constant term. So that's listing the factors of 8, which are 1 and 8, 2 and 4, negative 1 and negative 8. We have to include the negative factors, and negative 2 and negative 4. Now, negative 2 plus negative 4 add to negative 6, so we're going to select those. And we're going to write this left-hand side of the equation in factored form as x minus 2 times x minus 4, and we're going to set that equal to 0. So now we're going to use the zero product property. So if x minus 2 is equal to 0, then 0 times whatever x minus 4 is will equal 0. Likewise, if x minus 4 is equal to 0, whatever x minus 2 is times 0 is going to equal 0. So we need to set both of these equal to 0. So I'm going to say x minus 2 equals 0. And to solve for x, we're going to add 2 to both sides of the equation. So one of our solutions is x equals 2. Then we're going to set x minus 4 equal to 0. We're going to add 4 to both sides of the equation to solve for x. And so we've got x equals 4. Now you may be asking, what are these solutions, x equals 2 and x equals 4? Well, if you look at this on a graph, really in front of the x squared is a positive 1. We don't write the 1, but there is a positive number. So this is a parabola that opens up. And if I was going to do a very rough sketch, here's my x-axis. Here's my y-axis. And we go 1, 2, 3, 4. The parabola is going to cross at 2 and 4. So you're going to have something like that. I mean, again, rough sketch of the parabola. Anyway, so I hope you found this example interesting. Let's get to the next one. Okay, in this next example, we're going to solve for x again. This time we have x squared minus 7x equals negative 10. Now we see in this example, we don't have one side equal to 0, but we can get one side equal to 0 by simply adding 10 to both sides of the equation. So if I add 10, both sides here, I'm going to get x squared minus 7x plus 10 equals 0. Okay, so now what I want to do is I want to list the factors of the constant term 10. So those are 1 and 10, 2 and 5, -1 and -10, and -2 and -5. So I'm going to select -2 and -5 because they add to -7 here. So now I can write this in factored form as, or the left-hand side in factored form as x minus 2 times x minus 5, and I can set that equal to 0. Now using the zero product property, I know that if x minus 2 here is 0, 0 times whatever x minus 5 will be will equal 0. Likewise, if x minus 5 here is 0, whatever x minus 2 is times 0 will also be 0. So I'm going to set both x minus 2 and x minus 5 equal to 0. So I'm going to say x minus 2 equals 0, and we'll add 2 to both sides, and we'll get x equals 2. I'll also set x minus 5 equal to 0. And I'll add 5 to both sides. And I'll get x equals 5. So my two solutions are x equals 2 and x equals 5. And again, those are the two spots where this parabola would cross the x-axis on the graph. Okay, in our next example, we're going to solve for x again. We've got x squared plus 2 equals -3x. We want to get one side of the equation equal to 0, so I'm going to add 3x to both sides of the equation. Now the 3x cannot combine with 2 or x squared, and the way I'm going to want to write the left-hand side here, I'm going to want to write it x squared plus 3x plus 2. You don't want to get confused and think the 3 is your constant term or anything like that. 3 is the coefficient b, so we want to remind ourselves of that. On this left-hand side, -3x plus 3x gives me 0. So now we have one side of the equation equal to 0. I'm going to list the factors of 2. Those are 1 and 2, and we see those already add to 3. So I'm going to select these, but I'll also list, just for practice, the negative factors, which are -1 and -2. Again, we're going to use the positive factors, so +1 and +2, here to write our equation in factored form. So we're going to write it as x plus 1 times x plus 2. And that's going to be set equal to 0. Now, again, we're going to use the zero product property. So if x plus 1 is equal to 0, 0 times whatever x plus 2 is will be 0. Likewise, if x plus 2 is 0, whatever x plus 1 is times 0 will also equal 0. Okay, so I'm going to set x plus 1 equal to 0. And I'm going to subtract 1 from both sides. And I'm going to get x equals -1. I'm also going to set x plus 2 equal to 0. And I'm going to subtract 2 from both sides. And I'm going to get x equals -2. So this parabola will cross the x-axis at x equals -1 and x equals -2. All right, I have a meeting about to start, so this is going to be the last example. We're going to solve for x. We have 3x squared minus 18x plus 24 equals 0. Now you may be thinking, well, this doesn't seem like an a equals 1 type problem, but it kind of is. I wanted to show this one. We're going to divide 3 out of each of these terms, so we're going to change this to 3 times x squared minus 6x plus 8. Okay, so this actually becomes a lot like the first example now, except that we have a 3 times everything, but that doesn't really matter for the values of x. So next step, I'm going to list the factors of the constant 8, so 1 and 8, 2 and 4, -1 and -8, and -2 and -4. Again, I want this pair of factors to add to -6, so I'm going to select -2 and -4. And I'm going to write this in factored form with the 3 out front as 3 times x minus 2 times x minus 4, and that's going to equal 0. Now, if I look at this and I'm thinking about the zero product property, I can't set 3 equal to 0. That makes no sense. But if x minus 2 equals 0, 3 times 0 times whatever x minus 4 equals will be 0. Likewise, if x minus 4 equals 0, 3 times whatever x minus 2 is times 0 will also equal 0. So long story short, I'm going to set x minus 2 equal to 0. I'm going to add 2 to both sides of the equation. And I'm going to get x equals 2. I'm also going to set x minus 4 equal to 0. I'm going to add 4 to both sides of the equation. And I'm going to get x equals 4. So my parabola, which is the graph of a quadratic, it's going to cross the x-axis at x equals 2 and x equals 4. Now the 3 in front is just going to make it a little bit more steep. Anyways, that's it for this video. If you liked these examples and it was helpful to you, please like and subscribe. Thank you for watching.